Hey YouTube, welcome back to the BladesIIB shop and what I think is going to be a pretty fun project for us today. I know it's something new, different that I haven't made before, so I got to spend a little bit of time researching and learning how I was going to go ahead and make this. But today we're going to cut a new Pulley V pulley. So I've got a customer who is rebuilding an old Craftsman wood lathe, and this one, if you ever have an old lathe and they're taking it apart, it actually had 2 set screws in here, and he didn't find that in the instructions, so he undid the first set screw in the hole, pulled that out, and just thought it was super tight on there. So he used a puller and unfortunately bent this one out of shape to the point where it doesn't run very well anymore. He finally figured out there was another set screw underneath. That set screw on top was just locking it in there. So after he pulled out the second set screw, pulley came right off. But bottom line, this one is a little bit bent, a little bit mangled up. So we're gonna remake this out of 7075 aluminum. So that's gonna be the project for today. Again, I hadn't cut Pulley V grooves before, so had to do a little bit of research on the spacing, the sizing. We'll talk through that here a little bit, and I'll show you the drawing I made in Fusion of exactly what it is we're gonna go through and do. So before I take a look at the bench, if you're new to the channel, I would encourage you to get out there and check out the other videos on here on machining, welding, knife making, just any other project that comes through the BladesIIB shop. And if it's the kind of material you like watching, hey, I encourage you to hit that subscribe button and ring the bell. Make sure you know when that next video comes out. For those of you already subscribed to the channel, I sure appreciate it. I hope you like this video. All right, let's go ahead and take a look at the bench and what we've got set out and laid out on there. And then we'll dig into this project and get it going. Let's go. All right, as you can see, I already put together a drawing and made sure I've got all the dimensions of what it is we're trying to make here. We'll take a look in Fusion. I'll show you a little bit more detail around this drawing and exactly what we've got going on. But I will tell you that even though we're replicating an existing part, still ran into a couple of challenges with that. Because this is a kind of a soft pop metal, and because partly from that set screw, had pulled this a little bit out of round, and then also just from the puller being on it and pulling it off, really tough to get good accurate dimensions off of this. Just give you an example, on this outer diameter, it ranges anywhere from 3.206 to 3.270, 3.245, 3.211. Kind of get the same thing going on with some of these other steps on here as well. You know, you get 3.120, got 2.992. Yeah, that's a little bit more accurate. Let's see. So 3 inches and 20 thou down to, you know, again, almost 30 thou difference on that one. 589. It gets a little bit better as you get down here to the smaller one. You get 2.145, 2.146, 2.1475. So on this smallest diameter, it was a little bit more accurate. As we got further out, definitely a little bit harder to get accurate sizes. I did find that going across opposite of the set screw, I seem to get better dimensions. Bottom line, we're going to have a little bit of tolerance. So even when we hit these outer dimensions on here, I think if I'm plus or minus a couple, that's going to be our main concern. We don't have to be exactly perfect on that. I've got our width, I've got our groove spacing and everything set up. On the groove spacing for Pulley V belts, no problem finding online that they are all 40 degrees. So we are going to go in and grind a 40-degree tool bit. You'll see I've got it drawn on here very off center, because in order to get tight up there for that last groove up against the edge, I need to make sure that I'm well on the very edge of my tool bit to be able to do that. So we'll take over to the grinder and we'll grind that high-speed steel tool bit and make our grooving tool. You can also buy some inserts, but I only have one of these projects to make. By the time I bought an insert holder and the inserts, you know, that would just make this thing way too expensive to make. So we're going to grind a tool. But with that, on the spacing, so I was able to find that there are 4 different common spacings for these Pulley V belts, either 1.6 millimeter, 2.34, 3.56, or 4.7. So I did my best under a magnifying glass, and I measured the pitch between these grooves, and I was measuring them at about 94 to 95 thou. And when I found these dimensions online, that pretty much comes out to 2.34 millimeter, which is going to be our 0.0921 thousandths of an inch, since I'm using all inch dimensions. So I'm feeling pretty confident about the pitch, but we will go double check that before we cut one. When it comes to the depth though, didn't find anything on depth, and really it wouldn't matter anyway, because it's going to depend on the tool that we use and how I sharpen this. I'm not going to go to a very much of a point. I am going to put a radius on the end of that by hand. So we do need to figure out what depth we're going to cut to get these. Use some wires. I don't have any actual wires, so I'm using 2 of the same size drill bit. And I went through and I measured multiple places across that pulley and across this smaller one. And what I'm looking for is the difference between the outside diameter that I'm going to turn to and what measurement I get across the wires to figure out what is the depth we need to cut these grooves so that we'll have something to measure. So I went through, I did that in multiple places, and I came up with some variability. I came up with a smallest difference of only 40 thou difference between outer diameter and my measurement across the wires, all the way up to a high of 57. Somewhere around that 48 to 51 thou seems to be the average. I came out with 2 at exactly 48 thou difference, one of them at 51 thou difference. So feeling pretty good that if we're somewhere around that 48 to 50 thou measurement over the wires, that's what I'm going to be going for to figure out make sure we're cutting the depth of the grooves. So we're going to do a couple of different things. On this one smaller pulley, we're not going to rebuild this one, but it does have some damage on the end of it. So I am going to build a mandrel really quick. We're going to set screw, bolt this onto a mandrel, and I'm going to go in and touch up and just clean up that last groove so that you can run a belt on there. While we have this one set up, I will do a check and I'll make sure that our pitch is coming out at that 0.092 thou, so we'll verify that our pitch is correct, and I'll be able to touch off on this outside. After we make our tool, I'll see how far I'm turning that in to get a pretty good gauge of what depth we're going to be shooting for, and then we'll do a test cut on just a piece of aluminum. We'll test cut a couple of grooves, and we'll measure them with our wires to make sure that we know with the tool that we create how deep we're going to have to go, and then we'll just cut all of our grooves that same depth and we should be set. So that's the plan. All right, let's go run up to Fusion. We'll take a little better look at this drawing, and then we'll go ahead and come back down here. We'll get our tool ground, and then we'll start with cleaning up this piece, and then we'll go ahead and make this big pulley. All right, let's head up to the computer and take a look at Fusion.
Let's go ahead and take a quick look at the design of this part in Fusion 360. Now, I probably could have just scratched this out on a piece of paper, but even though this isn't that complex looking of a part, it's only got 4 outer diameters, a bore in it, it just has a lot of dimensions by the time you add in all the grooves, the spacing on those grooves, and everything else. So I really wanted to get a good design of this in Fusion. So here's what we're looking at, and as I mentioned, trying to figure out exactly what these outer diameters were. A little bit of a challenge since the part we're replicating was a little bit out of round. Wanted to get that set screw locked in there, and also wanted to figure out how I was going to counterbore this one from the back, a little bit different from the casting. I left a little bit of extra thickness on here for strength since I'm using aluminum instead of the metal. So like I said, I did want to go ahead and keep all of that the same. It wasn't too bad to design in here, so from a sketch perspective, turn on that first sketch, and there we go. Since the first sketch is pretty much exactly what I've got here, it's a little harder to see. But I just did a series of circles. I just did off of one center point, the circle for the bore, all 4 of those diameters. And then I just took and extruded all of those up into these different dimensions. They're all 0.335 deep, each one of these steps, to get my overall thickness. So that was all I did to build it, all a bunch of circles, and then just extruded all of those up the different depths to get that. To get the belt part on there, I went through and just did a sketch on the mid plane. So again, by this being the center, if I sketched it on that mid plane, I'm sketching right in the middle on a flat surface. So I went through and I sketched. I had to sort of guess on exactly what depth I was going to go with because I didn't know. I wanted to measure over the wires to figure that out. But I came up with a pretty good guesstimate on the depth. So I put a line in there at the depth off each of those edges, put in my 20-degree lines, and then I just went back in here and I did an inspection plane. And if you do an inspection plane with a section analysis, and you go off of this top plane right here, you can see that then I can cut it down to that section, and that way you can select all those pieces from your sketch. And then I just did a revolve, and I cut all the way around those to revolve and to get all my pulley grooves in there. So that part turned out not too bad, and then the final sketch was just on the back side. And again, just did a final sketch on the back, a couple of circles, and then went through and just extruded that back, the 330 thou off the back to get that counter bore in there. And then on the drawing, I went in here and just wanted to dimension all of this. So we've got our 4 diameters. We've got plus or minus easily 5 thou on those diameters that we need to hit when we get downstairs, because like I say, they were pulled up to 50 thou out of round. So I figured if I'm plus or minus 5, I'm good. Once we measure over the wires, we'll figure out exactly how deep we're going to cut those grooves. And as long as we touch off on that outer diameter and go a consistent depth, then we should get the real belt contact surface that we're looking for. That should be consistent across all 4 of those. We've got 335 thou deep on each one of these steps, so we'll go through and cut all of those. And then over here, I've got my dimensions for the counter bore. We're putting a 3/4 inch bore in there. We've got a 1/4 inch by 20 set screw going across. And then I centered up where these grooves were. So we've got 0.921 pitch between each of those belt grooves, and then we're going to have a little bit extra. We're going to move over 75 thou off of the front one. That leaves 75 thou off the back, so you end up with just a little bit of clearance against the shoulder for each one of those to make sure that that belt is going to be able to drop all the way in there. And that is, again, very consistent with matching up on that existing pulley that we have to model after. So looking online, finding the information about those Pulley V belts and the groove spacing and everything, feeling pretty good about the overall design, and it's going to make it a lot easier down on the lathe having a good picture to work from to make sure we can hit all these different dimensions. Let's head back downstairs. We've got a tool bit to grind up, and then we can get these things. We've got some parts to clean up in the lathe, test some of our dimensions on those other parts, and then we'll start cutting this big pulley. Let's head back down to the shop.
All right, if you've watched many of my other videos, you know I typically on my belt grinder, I'm grinding everything freehand for my knives, etc. But for this, we really want to get a nice, as close to a 40-degree angle as I can on this high-speed steel tool bit. So I put the tool rest on my grinder. You can see I've got some lines on here, so we want a 40-degree included angle. So I've got 20 degrees each direction so that I'll be able to line this up and keep it as close as I can to that 20 degrees. Going to start with a 60 grit, pretty rough belt on here to get rid of some of the material. And then I'll go down to a 120, and then I'll finish this up with a 400 grit belt to get nice finish on there. Trying to get a nice finish on the side of those V grooves when we cut them in the aluminum. So that's the plan. You can also see I've got this angled back. So I just kind of went with the same angle that's on the front of this tool bit. So I don't know, maybe somewhere in the 5 to 10 degree range. So that way I'm going to be cutting relief out of the bottom of this. When I get in there on the sides, same thing, that's going to give me my relief angle to make sure that we're only cutting on that top surface of that tool bit when it's in the groove, and we've got clearance everywhere underneath. So let's go ahead and get this sharpened up. Again, I'm really just going to cut on this side until I can see that we're going to be able to cleanly cut that groove without hitting our edge, and then taking most of the material off the other side here. So let's get this sharpened up. And I do have a bucket of water down here. We'll keep this nice and cool as we're working on it. Tell you what, we're taking a lot off of that one side. I'm going to go one belt coarser and see if we can't get rid of some of that a little faster, and then we'll go back to our 60. All right, we've got that pretty roughed out with that rough belt. Now we'll go down and we'll hit that with the 60 really quick, clean that up a little bit. Just get it to a little bit more of a point, and then we'll get our 120 and then a 400 on there. I am going to just pull a little bit more off of this edge for clearance. And you can see, you know, this coarse belt throws off a lot more dust, so I did put a respirator on using that coarse belt. But getting in here, we've got to get tight to that edge. So right now, it's not quite going to make it in there, and we definitely need to go a little pointier for sure. But I am going to hit over here, so I need to get a little more clearance back on this edge. It's really got to be very close over here to this edge of the tool bit. So I need to get rid of a little more material over here to move our point over a little bit more. Or actually what I can do is I'm just going to keep going off of this side a little bit more, I think, and push that point further over to this edge. I think that'll be better than taking clearance off of there. So we just keep pushing that a little bit over till we get our point a little bit closer over to the edge, and then we'll clean it up with our finer belts. Well, I feel like we've got a pretty good tool bit made here. A little tough to see, but if I get a good angle on it there, we've got the radius. We're getting to that full depth that we need. It seems to be hitting the sides. Looking at it with the protractor, feeling good about our 40-degree angle. And I ended up just going to 120 on that. I think that's a good enough finish on there. I didn't go to the 400. Even at the 120, I switched to a ceramic belt to try to get it to really remove enough material. So anyway, I think we've got a good looking tool bit. So let's go over to the lathe, and first we're going to clean up the shaft that this goes on. It's a little bit rusted, got some other marks on it. So we'll take a minute to clean that up, and then we're going to spin a mandrel. We'll mount that small pulley, and we'll test our pitch. We'll test cut a groove, kind of get an idea where we are for depth, and then we should be ready to make this part. Let's head to the lathe. Well, first I just want to get in here, and it's got a little burr on this snap ring groove right here, so it's a little hard to get things on this end of the shaft. Got a little rust around these threads. So just going to go in and clean this up a little bit to start with, and after we get this piece cleaned up, then we'll turn a mandrel to put that smaller pulley on. Well, there's still just a little bit of rust on those threads, but I would say that cleaned up pretty nice. We should have no burr left on that. Gonna spin it around, just clean up the rest of this shaft, and we'll move on to our next part. Alright, so to get this to fit on the shaft, it actually has a step down in there, so it is a little smaller at the end. We're just going to turn the end of our piece down here for clearance, and then it's a 5/8 bore in here, so it's like 625/5, so we'll turn 626. So we'll turn our shaft down to 625, should fit on there. And first I just need to turn that tip down to about 484, 485 to give clearance over that. About 83 thou we need to take off of there. About 27 more. Just looking for clearance over that, so we're good. Now let's get this down to 625. And I should have sped up the feed for that roughing cut. Just left it on that finishing speed. All right, again, we're going for 625. Right now I'm at 780 feet. There, take a proper finish, or rough cut, so we're breaking the chips. Got right at 55 thou left. tighter cut, finish feed, still breaking the chips on there. All right, I ended up about 1.5 over, which I want a nice snug fit, so I just want to perfect. All right, that's what I was looking for, was a nice snug fit on there. All right, so I've got that nice snug fit on there and here. And there's our spot on here that we need to clean up. But again, now that we've got this loaded, I can load our new tool bit that we just made. We can feed over between a couple of grooves. We can check our pitch, make sure that we have the pitch right, make sure that we've got the clearance on our tool bit to get in behind this sleeve. And then when we cut this one, we'll also be able to check our depth and get an idea of what we're looking at. And then obviously we'll do a couple of test cuts and do some wire measurements to just confirm our depth as well. But let's go ahead and get this one cleaned up. Check. All right, so we're gonna load that new tool bit that we just made. Get a blank tool holder here. We'll get this piece of high-speed steel out of here. We'll get that other tool bit in, get ourselves adjusted for center, and then we'll see what we've got over here. All right, we'll use my tool height gauge. Again, if you want to see a whole video of this being made, you can check it out. Now, I just pulled out another same size piece of high-speed steel, so yes, this tool is right on height, so we'll be able to pop this in and out as we need to change it, so that's good. Now I also want to check my tool for being lined up on here square, and I don't have a 40-degree fishtail, so I'm going to use my 60-degree here, and yeah, I can get a pretty good look at how we're doing for squared up on our piece. I think that's looking pretty good. Let's see what it looks like in one of our grooves here. I don't need near that much tool sticking out though, so I'm going to back that up a little bit. Okay, that looking good centered up in that groove. So I've zeroed my DRO. I want to move over that 92.1 thou. Okay, seemed like it was more 938. Let me go see how it is back to the other one. And that one is 918. So yes, or negative 918. So I think pitch at our 92 thou across the three of them, that worked. So we're good with our pitch dimension. All right, let me get a sense of where I'm touching off on that outer diameter. And we're going in about 142 thou for depth. Check that in another one over here. And that one I think is my one that measured a little shallow. That one's only 135. Let's go check one more. And that one's about 150. So yeah, I think somewhere about that 142, 143 for depth is about what I'm going to be looking for. Yep, 143 is what I'm getting on this one. And I feel like that has me right in the middle of that groove. 145, 143. Now if I go 92.1 thou, yes, that lines me up on that one. I just have clearance. So if I go negative 921, that should put me right in the middle of this one. All right, we'll see how I do. I should be lined up in the middle of that groove. I'm going to feed into about 143, and I should just be cleaning up that groove all around.
would say that did it. We got rid of our messed up edge. I went in there the 143 deep. Looks like it was tickling around just a couple of different places, so I'm liking our lineup. I like our tool angle. And the piece is running fairly true. You can see I hit the bottom around on one side, didn't hit around on this side. So I think our measurements, everything are lining up really well. I think we're ready to get in there and make this other pulley. Tool bit is set. Let's go ahead and chuck up that other big piece of aluminum. I'm gonna take off the collet chuck. I'm gonna put on that 3-jaw chuck, and let's go ahead and knock out this part. All right, we got our 3-jaw chuck on. We've got our piece in place. So we're gonna face it, turn the outside, and then once I get that outside diameter, we're gonna put that grooving tool back on, and we're gonna go ahead and cut a groove as well, and we're gonna see if that 143 thou depth, if that gives us the measurement over the wires that we're looking for, which should be about 48 thou larger than whatever outer diameter we turn it to. So we'll do a couple of those things to check it out, and then we'll start making and roughing out this whole part, get it center drilled. We've got a bore to put in there, so we'll go ahead and start machining. All right, I've got those jaws sticking out a little further than usual, so I do want to make sure that we're not going to have any interference over the carriage, nothing. We're not going to be going in that tight when we're done, but just to double check, we've got clearance over everything. We're good. Tried something different there with the DRO. I set it to what I thought was zero line, came out 486, and I went down to 450, and it took more than I thought it should. Interesting. Yeah, it didn't work. So I thought I would try something new, but I don't think it doesn't seem to want to center up properly, because it is reading 3.450 out here. If it cut it down to smaller than that, it cut it down to 431. So off by a full 20 thou. Interesting. All right, well, thought I would try something different for roughing this out and making steps, but we won't be doing that. We'll stick with our typical plan here. All right, so right now I am sitting at, I will actually call it 432, not 431. So 432 plus 48 thou should give me 3.480 over the wires. So I should measure 3.480 over top of my wires. Let's cut a test groove in here at 143 thou deep, and we'll see how we're looking. Well, it cut no problem at all. Let's see how we're doing with our wire measurement on that. Alright, measuring over wires can be a little tricky. Some people like to use like rubber bands or some other things, but I don't know, I just haven't really found the perfect way to do it yet. Once you get them lined up, it goes pretty smooth. Alright, so I say I'm getting about 487, so I think I need to go a little bit deeper. Let's do 145 instead of 143 and see what that gets us. Alright, I'm going to go ahead and come over one more, and I'm going to come over my 921 because then we're going to test our belt fit on here too.
right, we'll push to 145 on this other one. All right, 2 thou deeper, only went about 2 thou deeper. All right, went about 3 thou deeper. So let's cut our third groove and let's go ahead and punch it just a little bit further than that. Like in just a little flat we're seeing on the top. This time I went 47. Let's see. All right, belt fit. Well, that seems amazing. So our belt is definitely locking in there. Still have just little flats on the top. They're not quite to a point. I don't think I want to go much deeper though. Let's see how we're doing there. All right, I would say, yeah, I think we'll go with that, 147 deep. Well, that has given us our profile in there. We just cut those. Try and zoom in a little bit. You can see we've got just a little flat on top, nice radius in the bottom, good looking finish in there. See if I brush that out a little bit out the bottom. Yeah, you can see it brush that out. It's even a little bit nicer. So that should give us what we need to knock out the rest of this pulley. So let's go ahead and get this whole thing. We'll rough out the whole outside, get it drilled and bored. We'll get it all roughed. We'll go through and finish all our steps. And then we're just gonna cut all these grooves on there. Last step, we'll run over to the mill, drill and tap our set screw hole in there, and we'll be done with this project. All right, well, it's time to get on with the bulk of this project where all our test fitting, everything is done. So now I'm gonna go through and rough out this whole part. I'm gonna rough it out. I'm gonna leave 10 thou on the back of all those, and I'm gonna leave 30 thou on the outer diameter of each of them, and then we'll get it drilled and we'll get it rough bored out to within 30 thou. Then we'll go back, finish that inside bore while we're there, and then we'll come and finish that outside after it's all nice and cool. So let's just go ahead and start making some chips here.
Okay, let's see how we're doing on sizes. So I'm 258 on that outer one. I'm going to 223, so that's about 35 thou. And this one I'm going for 2.292, 3 and 12. So that is not 30 thou over. Interesting. That's only about 20 thou over. And this one I'm going for 2.585. And that one I am 615, so that one I'm 30 thou over. And this last one I'm going for 2.149, and I am right at 35 thou over. So a little bit of variability with my DRO as I'm going in, so we'll make sure we're taking good measure cuts off of there before we take our final finish cuts. But still a good way to rough it out. I'm roughly 35 thou over on each of those steps. So I've got those roughed out where I want. I did end up going full depth on this first one, so I'm going to take 10 thou off the front before we do our finish cuts. That way I can push all my steps back 10 thou when I finish those. So I did mess that up the first one. I went to the full depth. But let's get this drilled bored, and then we'll get that bore finished, and we'll finish off those outer steps. Well, I really need to get like a 5/8 drill or something like that. The largest drill I have is 1/2 inch, and then I jump all the way to 1 inch. So we've got to go to a 3/4 inch bore, and I'm just going to have to start with this 1/2 inch hole, and we're going to have to bore it out from there. Takes a little bit of extra time, so really need to get like a 5/8 drill that has a tapered shank on it so I can stack it up in here and drill out a little larger. But that's all right, we'll make do with what we have here. And I need to go in there 1.4 inches. Alright, we're at 672, going to 750. Roughly 78 thou left to go here. Alright, I took 25 thou. Let's see what we did. And it took pretty much exactly 25 thou out of there. So I'm going to slow my feed down to a finished cut. And this time I'm going to take 26.5 thou out of there, kind of split where I need to come out with on my finish cut. I changed my feed to my finish feed. All right, we should have right at 25 thou to come out of there. I just measured the shaft again. The shaft is already 1 under, so I'm going to go ahead and finish this right to 750. We should have nice 1 thou clearance on our shaft. Should be good. Alright, maybe getting about half over, so we should be good. Let's see how that feels on our shaft. Yeah, perfect. Alright, we're good on that one.
chamfer for that bore again after. Okay, 3.223. There's one done. All right, this one we're taking 19th thou. Missed that one by like 7th thou, not sure why. Alright, well again, we're kind of guessing on these sizes, so we'll be fine with a couple thou difference. That won't change RPM much, but wow, I'm not sure what I just did there. Did some math wrong. Well, there's the whole thing roughed out. We've got our bore in there. We've got all of our steps done. Came out pretty good. I'm spot on what I wanted on this top step. I'm off 3 thou on the next one. I'm a little bit large. No sense going any smaller. Not sure what happened on this step. I don't know if I measured wrong the first time, dialed wrong, but I ended up being off 9 thou on that one. Again, we've got a lot of variability in these, so not a big deal. And then I'm within 2 thou on the last step there, so we should be good. I'm gonna get in there. We're gonna put our grooving tool on and just knock out the grooves on all these. We'll part this off, turn it around, finish off our backside, and get our hole drilled and tapped in here. Just about done. We got one set done, and I know clearance is clearance, but wow, look at that. We just got that tool bit made exactly the way it needed to be to get in there to clear. We've got nice even step on this side and then on that inside shoulder. So we've got those nice and centered up on the steps on there. Just gonna keep working our way over, get all the rest of those grooves knocked out. Well, we just totally messed up the part here. I still am not sure what happened. I was having troubles with my DRO earlier. I went to cut this next groove over here. I zeroed it. I'm going down 140 thou, and it just went way deep. I could feel I was going too deep. I came out, I checked again on this one, and this one shows that it is still zeroed. And again, it wants to go way deep. Right now, I'm only 85 thou deep on my DRO, and it has clearly gone more than it needed to. It's like it quit doing diameter and it started doing just a plunge cut. So part scrap. I will definitely start again and knock out another one, but I've got to figure out what's going on with why my DRO is giving me such trouble here. Got enough material.
we'll turn it around and we'll knock out the part from the other side, but I am not sure what is going on with my DRO. Got to get that straightened out before I can make another one. We'll catch back up when I'm making grooves on that second one. See you in a bit. Well, I just did a little testing. I cut the 3 grooves up here. I cut the other ones down here. And it is truly, I've got a dead spot in my DRO. So now I understand why this one diameter, we turned 10 thou undersized, or 9 thou under. And the DRO just won't read there. I'm not changing any settings. I come out here to this one, using the dial and the DRO. It's reading properly out here. It reads properly here. Seems to read properly here. I'm just gonna save that so I've got something to hold on to when I turn this piece around. But there's like a dead spot on my DRO when it's over in this position. So I'll have to follow up with PM, get that taken care of. But for right now, I'm gonna turn this around and we'll be using the old fashioned. We'll be using the dials on the machine instead of our DRO, and we're gonna knock this part out again and get this thing complete. All right, well, we are caught back up, machined all my steps. This time I'm pretty much consistently 1 thou over on all of them. No 10 thou under or 9 thou under on this funny step where my DRO was having its little weird spot. So we've got everything. I did it all just manual on the diameters. My depth still seems to be coming out accurate, so I'm gonna go ahead and use that depth piece on here. I am going to put a magnetic dial on here. I'm gonna go ahead and put it on here as a backup. I'm gonna do manual for the depth, and I'll have a backup on here with this dial to make sure that I'm going the right distance every time, but I'm gonna trust, hopefully the DRO is working there. Let's go ahead and knock out the grooves and finish up this project. It's a good thing I'm doing it manual again, because that DRO is only reading 65, 70 thou deep on these when I am going the full 140 on the manual dial. So definitely got a glitch somewhere here on my DRO. Really weird that it's at just this one diameter. Well, our belt has clearance on there. We are good to go. All right, success this time around. Oh, this time all of our groove depths got in there nice looking equal, all nice and centered up on their individual step. We're gonna come in here, part this off, spin it around and face off the back side. You can see our belt just has nice clearance in there on each one of those steps. So other than a little DRO fail today, Nice, successful part so far, but we're not quite done. Let's get this parted off, face off the back side, and get our hole drilled and tapped in there. We'll wrap it up. All right, 1.340 is my finished. I'm gonna go ahead and part this off an extra 25 thou just to make sure it's nice, part straight, everything is good. All right, nice sturdy piece of plastic to grab that with. Almost through there now. And there we go. And I don't think this parting tool is meant to go quite that deep with my step over here on the other side. That's why it was getting a little tough there at the end, but that worked. All right, we'll get this turned around. We'll grab it nice and gently in there in the 3-jaw. Got a shoulder to push up against, and we'll just face a little bit here off of the back side. Get our hole drilled in there.
Hey, we barely made any jaw marks on there, so that is looking good. And once we get this done, I am going to put it on the arbor, and I'm just going to touch all those built grooves with a file. I should have done that while I had it on there before, but we'll do that after it's done, and that way we'll make sure over top of that set screw hole, everything, we'll just touch all of that with a file. Make sure that it's not going to tear up and chew up a belt on there. We're looking good. Let's head over to the mill. Let's get our hole punched in there and tapped. Alright, so I'm just going to find this fixed jaw on here, and then I'm going to come ahead where I need to line up right in the center of that groove. And then I'm going to find this edge over here of the vise, and I'm just going to get a square, line the square up there and just push this over so that it's just touching. It's almost in the center there, you know, where I'm on that edge line. And then I'm going to move over half the diameter of that outer diameter and get myself lined up in the middle. So that's how I'm going to center myself up where I want to put that hole. And then we'll punch a center drill hole in there, tap drill for 1/4 inch, and we'll get our tap down in there. Alright, we've got that. Let me do some quick math and we'll figure out where we want to be. Those steps are 0.335 each, so I want to come 2.5 steps ahead, so that's 8,375. Alright, there is 8,375, and the outer diameter on that piece was 3.223 divided by 2 is 1.615. Now I just want to find something nice, square, that pushes that up so that it's just touching there. Okay. Alright, I think we've got a good speed there now. Let's go ahead and get this in there. Alright, always one of those fun surprises. So this tap isn't quite long enough. I do have this spiral one that I think is a little less taper, a little more plug. Let's see if this will get just those last couple of threads out of the bottom of this. Alright, I got this spiral point one on there. Let's see what we've got. And, alright, yes. Alright, we broke through. Just barely had enough tap to get all the way through that hole. That's an awfully deep hole for 1/4 inch. So we just barely made it. That's good. Mounts on there, no problem. We got both set screws in. It's tightened up onto its flat. I'm not sure if it goes on. There's a little ring on here. I didn't tighten it too much. I just need to hold it in here to just touch a file on the outside of all those, and we'll see how true it runs on here. So let's go ahead and get it filed. And that is it. Time to call this video a wrap. As you can see, shop's a little messier. Making two of those, we flung lots of aluminum all over the place there. Let's take a quick shot of this all assembled and put together. So I did have to go back in there once I looked at the housing and needed to put a little bit more clearance on the back side of that pulley just to get the slide back far enough for that to line up. But we have good alignment in there now and should be ready to run. All right, let's wrap up this video. Well, YouTube, that's a wrap on another video here in the BladesIIB shop. Hope you enjoyed it. We got to make another one of these Poly V pulleys, a little bit of research, learning how to cut these grooves, the spacing. So a good learning project for me. Hope you got something out of it. And I think the customer will be happy replacing that one that they had. Been a while since I got to make something twice, so we got to work through a little machine issue with the DRO. Good learning with that as well. Able to spot that right away and just went back to doing some manual machining until I get that DRO fixed and taken care of. Hey, if this is the first video you found on the channel, again, I encourage you to get out there and check out the other videos on here on machining, welding, knife making, just other projects coming through the BladesIIB shop. If you like what you see, would love it if you hit that subscribe button. For those of you already subscribed, as always, thanks for watching. Hey, until next time, I hope you're out in your own shop working on some projects of your own, making a mess of your own like I got to clean up in here. So while you're doing that, I'll be working on that next video for the channel. Until then, y'all take care.